Hi, hi, we are Group 21, and our topic for this project is extracting event details using social event detection. The problem statement is that there are a lot of websites in the market for booking tickets for events like plays, uh, games, and concerts. And the main problem in these websites is that they show the events only what they have in their database. And for this project, we have taken two ticketing websites, and those are SeatGeek and Ticketmaster. They both don't have all the event details. Like some of the events that are present in SeatGeek, they might not be present in the Ticketmaster, and vice versa. So, in order to overcome this problem, we have developed this application to get the data from these websites using the linked data, and we display the results by eliminating the duplicates from them. Thank you.
Thank you, Jonathan. Um, so I will be talking about web scraping that we have performed to fetch event data from Ticketmaster website. We have used Python script and request library for scraping this data. As we can see here, we fetched data from the API by using this URL here, and uh, so in this URL, we have obtained the client ID or the API key by signing into the Ticketmaster website. Um, so here, as you can see, we are trying to convert the JSON, the data to JSON format, and here we are trying to convert the JSON data to a CSV file with appropriate headers. And this CSV file is later used in Protege while using Selfie plugin to create instances. And I have also worked the on creation of the owl file, and also uh, uh, worked on Angular part. That's it from my side.
Thank you, Dhaneshwar. Hi, this is Rohit, and now I'm going to explain about the high-level design and about the ontologies and how to populate the ontologies using Selfie plugin. So as you can see, this is a high-level design. So we have a user interface where the user enters the required fields such as name, city, or state in which the events happen. And that request goes to the backend, which we have done in Spring Boot. And in the backend, we use the endpoints which we fetched by creating two AWS EC2 instances. And in the AWS EC2 instances, we run the Fusiki server by which we can query the SparkQL queries. And that endpoint, we provide that endpoint in the backend, and using that, we fetch the results based on the user queries and give it as a JSON response to the user interface where the results get displayed as a table, the required results, the venue name, the venue address, and the event name, etc. These details get displayed at the user interface. So this is the basic, this is the high level design. And now coming to the ontologies, based on the data, we now I'm gonna just explain one ontology file, which is SeatGeek, which we have fetched from the SeatGeek website. So as you can see, these classes are the attributes or titles which we have fetched using web scraping. So we have created various classes based on these attributes such as date, time, ID, performer name, and we have created object properties based on them, such as the title has date time, title has ID, the event title has performers names, has state title, and we have also created data properties as well. So date time will be of data type date time. So this way we have created the data properties. So yeah, so now regarding the populating the instances into our ontology, we use selfie plugin, which takes the data sets in the form of Excel sheet. So as you can see, these are the data sets we extracted from SeatGeek website. So now using the translation rules, which column in this Excel sheet has which column in this Excel sheet has object property which column in the data sheet, and in this way you write the transformation rules, and once you press the generate axioms button, your instances get populated onto your owl file, onto your owl file such as this way. So this you once the individual instances are populated, you then manually write the object properties and data properties in the owl file. So this way we create the required instances. So yeah, that's it from my side. And I also worked on the SparkQL queries by which we can generate the required information from the two websites, Ticketmaster and SeatGeek. Thank you.
Hi, this is Prasuna. I have worked on AWS setup and physical server setup. Firstly, we have created two instances, two EC2 instances, one for each website we have scraped data from. And each of these instances were added with a security group rule. As we can see here, each of these run on the port 3030. When we have created, it also creates a PEM key for us that will help, that is used for the authentication. And so you can see here, this is how we run. This is how we connect to an EC2 instance using the PEM key we have downloaded when creating that instance. And also here we give the public DNS of that EC2 instance. And this is how we connect to that instance. Yeah, and in this instance, which acts as a virtual computer for us, we have set up Java and Physics server on each of these instances. Now we navigate to our desired folder, and we have this command which runs the Physics server for us by creating an in-memory data set. Now we're doing this for SeatGeek website we have used. As we can see here, when that is run, port 3030 is active now, and this is what we see. Now, when we upload our owl file that is created by using the selfie plugin Rohit has explained, when we upload this, now, as we can see, when we upload it, triples are created for us. And we can query, like write a SparkQL query right here to get desired results. But we have also done this in our code base. Okay. All right. Now, coming to our code base, we have first created a class called events that has all the attributes that are related to our event details. We have used Spring Boot for our backend development. And we have this class that is used for all the computation that is done to write the queries and get populating the results and returning it to the front end. As you can see, this is the URL that we were earlier using to connect to that SeatGeek Physics server. And this is how we write the queries based. we have these many queries, but each of these executed based on what the user wants, based on the input the user provides from the front in the front end. And after populating all these results in a list, at the end, we return it in the form of a list of events to the front end. Now, Nikita will discuss how we develop the front end.
Hi, I'm Nikita, and I have worked on UI implementation and integrating it with the backend. So we have used Angular 10 and TypeScript for front end, and IDE we have used is Visual Studio Code. And I'm starting front end server using the command ngserve. And also the backend server, I'm restarting the server. So for UI, we have created a form to take input from the user, and the input fields will be event name, city, and state. So I'm giving the input as Phoenix, the city, and Arizona in the state. So we can see the output we have obtained, and the fields in the output are like event name, venue details, event time, and performer details. And I'll enter one more input with city San Francisco. So here the data obtained is integration of two data sets, and that is what we're displaying in the output. Yeah, thank you.
Thank you.